Good morning to all. We have chosen India's AQI for Capstone project, and we have done descriptive and predictive analysis on the data related to AQI of different cities. Hi all, my name is Chitra from Group 5. My other team members are Akash, Ananya, Garima, and Vaseem. In today's agenda, we'll cover a brief introduction about data we have used, and as a part of predictive analysis, we'll see different models and its accuracy level. Since we all are witnessing degraded quality of air, majorly in metro cities, we thought of working on this practical situation we are facing on it in our daily lives. Data has been taken from Kaggle for the year 2015 to 2020. And previously in the descriptive analysis, we have actually shown the status of AQI in different cities and the reason behind that situation, that why it has happened. So today, with the help of Orange and Python, we are predicting the best model that can be used further to anticipate the AQI in the coming years. So let us have a look at the data. So in today's data, we have 29,531 rows with 16 columns. And among 16 columns, all the pollutants are considered as independent variable, whereas AQI rank is we are considering as dependent variable. AQI rank falls under different categories, that is from good, average, poor, very poor. And that's all from my side. Now I'll request Ananya to take it from here.
Thank you, Chitra. So for predictive modeling using Python, we have used some of the algorithms which we will be showcasing in the following slides. We have used various algorithms to do a comparative analysis to understand which algorithm is best fit for our model. Now we have used we have prepared the slide data set. In this part we have cleaned the data, removed for where we do not have any AQI values, and then we have given the values a ranking like for good, moderate, or for all the AQI buckets: good, moderate, poor, very poor, and satisfactory. Then here we can see the X portion data set, which are the independent variables, and then the Y section, which is the dependent or target variable, which is the AQI ranking. We have also used the interpolation method, forward and backward interpolation method, to fill up the gaps where we do not have any data. Moving on to the next slide. Now we have these following models, algorithms for are predicting our data. First, we have used the decision tree classifier. As you can see here, we are getting the confusion matrix as well as the accuracy score, which is coming as 0.73, which means 73%. Then we are coming to logistic regression and SVM. For logistic regression, we can get confusion matrix as well as this accuracy score, which is 0.52. And for logistic regression, we are getting the score as 0.74. Moving on to the next slide. Here we are having random forest and KNN. For random forest, we are getting 0.81, and the confusion matrix we can see in the slide. And for the KNN, we are getting a score of 0.76 as well as the confusion matrix. Moving on to the next. Finally, we have this naive Bayes algorithm, and here also we are getting the accuracy score of 0.62. So we can see that out of all of these algorithms, we have done the comparative analysis, and for the random forest, we are getting the maximum accuracy score. So I'll let Garima to explain further on Orange.
Thanks, Ananya. In addition to the Python code, we are using Orange, which is really a powerful tool that could help us use the classify models, and it help us to give the values of testing and the scoring and the confusion metrics, which gives us the accuracy rate in testing and scoring. Here we could understand which model would be the best suited model for our data sets. So as you can see, this is a drag and drop tool, and we are using different models like random forest, logistic regression, KNN, SVM, neural network, naive Bayes, and gradient boosting. Comparing all of them and fetching their results in this form, here you could see there are different parameters where we could match the accuracy, like area under curl, precision, recall, and all. So hopefully it's quite visible that in random forest we are getting the accuracy of almost 100%. And likewise, in other models, we are getting a little lower, with naive Bayes having good score for area under curve and gradient boosting also. So we did this comparison for area under curve, and if you see this matrix over here, for the random forest, which is better than gradient boosting by 0.25 4 score. So this is why we thought of taking it as our model for the predictive analytics for the respective data. Here you can see the confusion matrix of the random forest, and it's quite visible that it is matching up with the values that were actually there in the data and what our model had predicted and given it to us. So you could see that actually there were 1341, numbers of data records for ranked 1 AQI, which is the good AQI, and the predicted one is also giving up the same score. Likewise, for ranked 2 AQI bucket, the values are identical. Moving on further, for all the data that we have, it is giving us the best result. So we thought of choosing random forest for as a best model for our data. So looking at the comparison here in the slide, you can see the Python code is also giving us the highest accuracy of 0.81. And here also it's giving up the maximum accuracy under different parameters like area under curve, precision, recall, and all. So this is the best suited method for our data, and hence we are using this random forest method for the predictive analytics of the AQI data. That's all from our side, from group 5. If there are any questions, we are more than happy to answer them. Thank you, everyone.